Hello and welcome. Today, we are diving deep into the absolute foundation of Google Cloud, Compute Engine. Seriously, if you've ever wanted to understand the real building blocks of the cloud, not the fluffy marketing stuff, but the actual nuts and bolts, then you are in exactly the right place. Let's get right into it.
I mean, really think about it. The apps you scroll through every single day, the websites you shop on, the online games you play with friends. What is actually happening behind the scenes to make all of that work? It kind of feels like magic, right? But it's not. The secret is that even the most massive, world-spanning applications are all built from pretty simple, fundamental pieces. And today, we're going to learn how to use the most important one of all.
I want you to imagine the cloud as this huge, empty plot of land. It's your digital construction site. And Google Compute Engine? That's the service that delivers all the raw materials, the heavy machinery, everything you need to build whatever you can possibly dream up. And the most fundamental material of all? That's the virtual server. So this is called a virtual machine, or just a VM for short. It is your very own private computer that lives inside one of Google's giant data centers. The hotel room analogy is perfect. You get your own secure, private space. You can set it up exactly how you want with your own software, your own code, and when you're done, you just check out. You're not buying the entire hotel, you're just renting the room you need for exactly as long as you need it.
Okay, so let's lay that first brick. When we go to create our very first VM, there are a couple of really crucial components we need to wrap our heads around to get it right from the very beginning.
First up is the storage, and this is called a persistent disk. Now, here's a super important point that trips a lot of people up. In the cloud, the hard drive is actually separate from the computer itself. What does that mean for you? It means you can completely shut down your VM to save money, but all of your data, your files, your configuration, it all stays perfectly safe on its disk, ready to go for the next time you start it up. That separation is an absolute game changer.
All right, so our VM is up and running. Awesome. But, it doesn't live in a bubble. It's probably going to need to access other things, like a database, or maybe a storage bucket. So how does it prove it has permission to do that? You definitely don't want to be storing passwords in your code. That is a massive security risk. Well, the answer is something called a service account. Just think of it like a digital ID badge for your VM. This badge has a very specific list of permissions on it, like you are allowed to read data from this database. So when your script runs, the VM just flashes this badge and Google Cloud says, okay, you're good, and grants it access. No passwords needed. Seriously, this is a huge one for beginners. If your script can't connect to another service, checking the VM service account permissions should be the very first thing you do.
All right, so we've built our application, it's up and running, and what happens when it's a huge success? Suddenly, you have a very good problem on your hands. This is the best problem to have, right? Your app is popular, but success means more traffic, and a single VM can get totally overwhelmed. During that busy lunch rush, the app slows to a crawl, and users are starting to complain. You need a way to handle that demand without paying for a gigantic server that just sits there doing nothing all night.
And the solution is auto-scaling. It works exactly like a smart thermostat for your app. When traffic heats up, it automatically spins up more identical VMs to share the workload. And when things cool down later in the evening, it shuts those extra ones down so you're not paying for them. You get the best of both worlds, happy users and a happy wallet. So how do you actually set this up? It's like setting up an assembly line. First, you build one perfect VM, get it all configured just right, and you create a master copy of it. That's called a custom image. Second, you write up a blueprint, an instance template, that basically says, build all new machines to look exactly like this master copy. And finally, you hire a factory manager. That's the managed instance group. And its only job is to watch the demand and use your blueprint to build or remove machines automatically. Okay, we've built our application and we've made sure it can handle a crowd. Now we have to lock the doors and secure the property. Just like any valuable creation, our digital one needs some strong fences and a few security guards. Your first line of defense is a firewall rule. This is the bouncer at your club's front door. It inspects every single connection trying to get to your VM, and it checks it against a list. If that traffic isn't on the list, it gets denied. This is so important for things like a load balancer, which sends out little health checks to make sure your VMs are okay. If your firewall blocks those checks, the load balancer will think your app is down and poof, it stops sending users to it. So firewalls are great for managing that public entrance. But what if you don't even want a public entrance? For really tight security, you might want your VMs to be completely private, with no public IP address at all.
So how do you, the developer, get in to manage it? This is where Identity Aware Proxy, or IAP, comes in, and it's awesome. Think of it as your secure VIP list. IAP creates a secure tunnel that completely bypasses the need for a public entrance. It doesn't care about the VM's IP address, it only cares about your identity. If you're on the list, it lets you connect securely. If you're not, the door basically remains invisible. Every construction project has a budget, and ours is no different. Building in the cloud is incredibly powerful, but you also have to be smart about the costs. So let's look at a couple of key ways to spend wisely. So, how do you get the big discounts? There are two main strategies. For servers that you know have to run 24/7, like your main production app, you make a deal. You tell Google, hey, I promise to use this for the next year, and in return, you get a huge price cut with a committed use discount. But for jobs that can be interrupted, like processing a giant batch of data overnight, you use spot VMs. These are ridiculously cheap, but there's a catch. Google can take them back with very little notice, so they're perfect for anything that isn't super time sensitive.
But beyond all the fancy discounts, the simplest truth is this. The best way to save money is to just turn things off. Think about it. Your development and testing servers, do they really need to be running all night or over the weekend? A simple automated schedule to shut them down outside of work hours can literally cut your bill in half.
Okay, final section. We've built it, we've scaled it, we've secured it, and we've budgeted for it. The last step in our construction project is making sure our building is earthquake-proof. We need to be ready for the unexpected. It's rare, but it can happen. A fiber optic cable gets cut, a major power failure, and an entire data center facility, what Google calls a zone, could go offline. If your VM and its disk only live in that one zone, well, your application is down. So how do we survive something like that? The answer is the regional persistent disk. This is a special kind of storage that literally lives in two different data centers at the same time. It's actively replicating your data across two zones, so if one of them fails, your data is already safe and sound in the other one, ready to be attached to a new VM in just a few minutes. This is the real secret to building apps that can survive a major outage. So let's just step back and look at the blueprint we've put together. The virtual machine is your core foundation. Autoscaling is your plan for expansion. Firewalls and IAP are your security system. Committed use discounts and spot VMs are your budget controls. And finally, building across multiple zones is your insurance plan. If you can master these concepts, you have truly mastered the fundamentals of Compute Engine. So there you have it. You've got the blueprint. You understand the core components, the strategies for scaling, for security, for cost, and for reliability. The digital construction site is open, and all the materials are ready and waiting. The only question left is, what are you going to build?